So let us now have a discussion on the infinite series. If u1, u2, u3 and so on, un, and again after that you have un plus 1, un plus 2 and so on, is an infinite sequence of real numbers, then the sum of terms of the sequence, that is given by un plus u2 plus u3 and so on plus un, and plus un plus 1, un plus 2 and so on up to what u infinity, is called an infinite series. Okay, the infinite series, what is denoted? Okay, so it is denoted like this. Okay, so it is given by summation n from 1 to infinity. So you can write like this: summation n equal to 1 to what, infinity un. You may sometimes start your series from n equal to 0 also. Okay, so in that case what you may have added term u0 plus un plus u2 and so on up to un plus and so on up to u infinity. That also is correct. Okay, sometimes it is simply denoted by summation uns. Okay, even it can be denoted by s. So s means it is summation of infinite terms of a sequence, that is series. Okay, so what is infinite series? It is just addition of, it is just sum of infinite terms of a sequence which of real numbers. Okay, now let us have first n terms of a sequence. If u1, u2, u3 up to un, okay, I am going to consider this part only, not the terms after un. Okay, for fixed n, then un plus u2 plus u3 plus and so on up to un, it is called partial sum and it is denoted by sn. Okay, so summation n from 1 to infinity, yes, we can bifurcate it as summation n from 1 to n un, then it is called a partial sum. Okay, so it should be from n to n from 1 to n, not from n from 1 to infinity. So summation n from 1 to n un, yes, it is called a nth partial sum. Okay, so what is third partial sum? So it will be un plus u2 plus u3. What is fifth partial sum? un plus u2 plus u3 plus u4 plus u5 and so on. What is nth partial sum? So it is un plus u2 plus u3 and so on up to un. Let us discuss regarding the convergence and divergence of infinite series. Okay, so now let us consider an infinite sequence is given by summation n from 1 to infinity un. So here you can see that this is starting with n equal to 1 and ending with n equal to infinity, and let us consider its a infinite sum, its a partial sum, and its partial sum will be given by what, sn, and sn is equal to what, un plus u2 plus u3 up to un. As n tends to infinity, if you take what, the limit of this, as n tends to infinity we get some limit. Okay, and if that limit n tends to infinity sn of that partial sum, okay, is finite, then we say that the series is what, convergent. Okay, if it is infinite, then it is called a divergent, and if that if this limit is not fixed or does not exist, in that case we say that it is oscillatory. So if limit of limit n tends to infinity of sn does not exist, okay, then that series is oscillatory. So that is the definition of your convergence, divergence and oscillations of series. Now let us have examples. Before that, let us have some properties of infinite series. Okay, so first property, is like this. The convergence or divergence of an infinite series remains unaffected by addition or removal of infinite number of terms. Okay, so if you remove what, the infinite terms, so if you remove the finite terms, if you remove 2 terms, 5 terms, 10 terms, 100 terms, 200 terms from any, or if you add same number of terms okay, in a series, then what, its convergence divergence is unaffected. That is meaning of the first. Even if you multiply each term by a finite constant, okay, even in that case also the convergence and divergence of the series is unaffected. Means if the series before addition or before removal is convergent, then after adding or after removal of some terms, finite terms, still it will be convergent. And same is the case for divergent. Okay, so for the case of multiplication, suppose that you have certain series. Okay, if you multiply, so let me have an example. Suppose that you have series u1 plus u2 plus u3 plus u4 plus and so on. So if you suppose that what you delete some term, suppose that you have deleted this term, and suppose that you have deleted this term, and so on, something like that. So in that case, if this series is what convergent, after deleting of finite terms, still it will be convergent. If it is divergent, then again it will be divergent. So what, by multiplication by a finite constant, by removal or addition of finite number of terms, okay, the convergence and divergence of a series is unaffected. Okay, then if two series converges, then their sum is also convergent. So suppose that you have u1 u2 u3 u1 plus u2 plus u3 and so on up to u infinity, yes, is a first series, and you have v1 plus v2 plus v3 plus and so on, vn is a second series. If what both are convergent, then their summation is also convergent. That is u1 plus v1 plus u2 plus v2 plus u3 plus v3 plus and so on, un plus vn plus and so on, u infinity plus v infinity. This series also will be convergent if both that series are convergent. Okay, now let us have a most important thing, that is regarding the necessary and what's necessary condition for convergence of infinite series. Now this we are going to use rarely. Okay, this we are going to use rarely. It is used for very few, but its complement, okay, or its negation statement will be rigorously used. So what is negation statement, that we will see. Before that, let us see what is necessary condition for convergence of infinite series. If a positive series, means all the terms of what this series are positive, un is positive, u2 is positive, u3 is positive and so on, that is meaning of a positive series. If a positive series is convergent, so if you have positive series which is convergent, it should be convergent, then what is happening, then it happens that what limit n tends to infinity un is equal to 0. So its nth term, if you take what n tends to infinity limit, then it what becomes 0, it converges to 0. That is meaning of this. So if you have convergent series of positive numbers, positive series, okay, which is convergent, then its what limit n tends to infinity un will become 0. So it is one way statement. What is its negation? Okay, you know that if p implies q, okay, in logic gates, we have seen logic statement, we have seen if p implies q, if p happens, okay, then q happens. If it is what statement like this, then negation q, okay, imply what, negation of p. What is meaning of negation? The opposite thing of whatever we have. Okay, so if p is happening, what is meaning of p is happening? If what un is convergent, what is negation of it? What, summation un will be divergent, negation of that. What is the negation of limit n tends to infinity un equal to 0? It will be limit n tends to infinity un not equal to 0. That is what we have written here. So negation q, okay, negation q implies negation of p. Note that this is the statement of q and this is the statement of what, p. Okay, let me clear out again. So this becomes your what, statement p, and that imply what is happening, q is happening. Okay, so p implies q. What we have? So we have p implies q. Okay, and by logic statement what we have, negation of q implies negation of p. Okay, what is meaning of negation of q? The what complement of limit n tends to infinity un equal to 0 is limit n tends to infinity un is not equal to 0. So what is negation q? Limit limit n tend to infinity un is not equal to 0. This is here. Okay, what is meaning of that? Yes, the series summation un will be divergent. So summation un, this is your q statement. So summation what, n from 1 to infinity un diverges. So negation q imply negation p. Okay, p implies q, this is p implies q, and what this imply, negation q implies negation p. Okay, so if limit n tends to infinity for a certain series, okay, is not equal to 0. Okay, so what is meaning of that? If you have nth term of some certain series, and as limit n tends to infinity of that term is not equal to 0, it is not equal to 0 means it is anything other than 0, then that series, if it is positive series, then it diverges. Okay, so example we can have, suppose that you have series 1 plus 2 plus 3 plus 4, suppose that you have this series. Okay, so this series is having nth term equal to n and plus and so on. Okay, and you will find that limit okay, here this is your un, this becomes your un. So limit n tends to infinity un is equal to what, limit n tends to infinity n, and if you put what, n equal to infinity, limit n tends to infinity of infinity is again infinity, which is not equal to 0. So see, this is very very useful condition. If nth term limit as n tends to infinity is not equal to 0, if it is other than 0, then definitely that series what, diverges. So this series is a divergent series. So this a form of a series is what frequently used. Which one? Negation q implies negation p of this statement, necessary and sufficient condition. Okay, you can see I have written a series 1 2 4 8 and so on. Okay, you will find that this series also diverges. Why it diverges? Because the nth term of the series is 2 raised to n minus 1. Okay, so 2 raised to n minus 1 is what, your un. Okay, and you will find that that un as limit n tends to infinity, what will become infinity, which is not equal to 0. Therefore this series what, diverges, this series diverges. Now next part is regarding your geometric series, that we will see in our next video.